For today's lecture, I would like to review some of the maybe exercise and also just review the topics, what you need to please to emphasize. Okay, let me start with giving the brief topics. What will we have in the final exam? Okay, so final exam. The topics should be from chapter 5. Okay, chapter 5. Chapter 5 will include the indefinite integral, the fundamental theorem of calculus, okay, which means if fundamental theorem of calculus included, then you need to connect this with some of the knowledge on derivative, right? Okay. For example, still you have the how to read a graph, because we will have now the functions probably in a way that we have in integrations. That is having fundamental theorem of calculus when you try to derive, okay? Which means you need to categorize, increase, decrease, okay? Inflection point is still there, okay? And also it's connect to the indeterminate forms, okay? Indeterminate forms. Which means it will be sum of the limit, okay? But the limit will have an integral, okay? But this is just a few, okay? Few questions about this. And then chapter 5 also talks about the use substitutions. Okay, so it's related to techniques of integral. And then chapter 6, okay, chapter 6, area between curves, okay, area between curves. And then volume. Volume, you have two kind of method, the disk method, or sometimes we call the washer, that's having the, some hole, okay, in the middle. This is the disk, is the without hole. And then the second method we call the cylindrical shell. This is based on the pi r squared, okay, pi r squared, and r usually functions or a variable, and multiply with the height. And the cylindrical is 2 pi rl. And then the chapter 6 also about the average value. Okay. And chapter 7, this is all about the techniques. Techniques means the more advanced, like integration by parts. Trigonometric integrals. Trigonometric substitutions. Remember, you can sub for sine, substitute for cosine theta, secant theta and tangent theta. This is 4 substitutions that are common. Also, we have a partial fraction. And we also have the improper integral, right? Okay, I think that's most of it for the techniques. And chapter 8, we have the arc length and surface area. And I think we will start some exercise from chapter 8. Okay, chapter 8 here. Okay. So I think we begin for the practice. Okay. I hope we can have more exercises. Okay. Let me check. Okay. Okay. Now we have these 2 questions. It's from the textbook, and I think this is interesting to see. So we have these 2 questions. The first one is just to show that the surface area is infinite, but the volume is finite. Okay? So it's one phenomenon in mathematics. Uh, if you calculate the volume, you will find that there is a value here. But if we evaluate the surface, it's going to be infinite. Okay, we will see. Okay, and the second one is to find the area. Okay, area of residential surface. Okay, let's see for number 33. Okay, now the question itself, okay, it's rotated. So we have the curve. Let me clear screen. Okay, so we have this functions. Okay, 1 over x. We start from x equal 1, so we start from here, and we rotate the whole curve. Okay, we with x-axis as the center. So we rotate here. Okay, now if we rotate through x-axis, now the radius is become this, right? Or let's say, let me write in the middle to make it more clear. Okay. So this is the radius. Okay, so we can write this surface number 33. The surface is 2 pi or we can write here from 1, okay, from 1 until infinite point, okay, and the radius is y, and it has the arc length. Okay, so arc length will be here, the L, right? Or let me just write directly 1 plus dy over dx squared, and then dx. Okay, and then because I'm using dx, so we can just change all into variable x. And inside here, the dy dx is negative 1 over x squared, right? Okay, and then this will become 1 over x with power of 4. This is the x. Okay, and we solve, we simplify a bit. Okay. Okay, because the question is just to show that the surface area finite or infinite. Okay, then we could see that let's take the note that the square root of x with power of 4 plus 1 is larger than the square root of x with power of 4, or x squared, for x positive, right? Okay, and then we can write that this will be larger than, and since this is equal to 1 over x dx, and remember in the improper integral we know that at the, if we have p, if p is less equal 1, this will be diverged, right? If p is greater than 1, this will be converged. So since diverge, then area S is infinite. Okay. So the surface area is infinite. You can try to find the volume, and you will find the volume is actually, it's finite. So it's actually one phenomenon that, to show that there is one conditions that shows the surface is infinite, but the volume is finite. This is number 33, the Gabriel's horn phenomenon. Okay. Okay, now with the similar formulations, we could also tackle number 34. Okay? Number 34, if the infinite curve, we have this, okay, this when x is positive, we have e with power of negative x. So we should have the same formulations, but now we will have 2 pi. Now it will be e with negative x, and 1 plus e negative x squared. And then the x. And then we could use the substitution method. I think we could use substitution method. U is e with negative x. So du will be negative e negative x dx. So we will have some sort of integration with u. Let me write here. Probably it's better here. square root of, square root of 1 plus u squared du. And then we could try to take this integral. I think we could take it into by parts. We could take it, I think. Okay. Let me wait for a moment. Okay. Yeah, you could check this out, the formulation for number 34. Okay, so this is if you want to take notes first. Okay, another questions that I want to emphasize is some short questions about the arc length to give you more familiarity with the arc length method. Okay. Okay, just to show you the this is just a direct questions. Find the exact length of the curve. Okay. I have at least 8 questions here, but I will probably just take maybe 2 questions at most. We can try number 11 and then maybe number 13. Number 11, 13. Or probably number 16 also. Okay, number 16. No, 16. Maybe 11 and 16. 11 and 16. And let me make it a little bit smaller, maybe here. Okay, let's start number 11. So number 11, if you see what we have here, the length of the curve, what we are going to do for the first steps is, my suggestion, okay, for you is to take the derivative first. Okay, so take derivatives. Okay, so take derivative of this. Okay, so we are going to put here going down. So it will be canceling, and then don't forget the chain rule for the x squared. So 2x. Okay, so 2x, 1 plus x squared, and then the power will be minus 1. It's supposed to be half. Okay. And then what we are do next is we take the square. Well, let me write with the color red. So we will have 4x, right? 4x squared 1 plus x squared. Okay, and then don't forget to plus 1. So this will be 1 plus dy dx, and this will be also plus 1. Okay, so this is what we need to take on into our arc length formulation. So we take the arc length formula. I mean, we write in black. So arc length from 0 to 1. Okay, from 0 to 1. So 1 plus 4x squared, 1 plus x squared, and then dx. Now it seems, okay, for some reasons, okay, when you deal with this arc length, because you will have a square root, okay, you will have this square root. Uh, in the final exam, what I was preparing is a question that is having at least whole number or a really good number or a fraction that is good to write. Okay? So if you are not able to maybe finding that number that is really convincing, maybe you should try to look on your process. Maybe there is something wrong in between. Okay? So you can check it out. But if this questions is on at least um, in the last part of your finals that you need to write in your paper, I will see your steps, okay, and I will give points based on your necessary steps. If it's correct, but you still that doesn't get the correct answer, you still get a point, okay? So this we can first we try to solve it. We try to solve it. So perhaps we are going to just multiply. So we will have 4x with power of 4 plus 4x squared and then plus 1, right? Let me check. 4x squared, 1, 4x 4, and plus this, right? Oh, wrong. This is different. So I need just to multiply this and this, right? Because this one is outside, not inside the bracket. Okay, sorry. So this is correct. Okay. Okay. Now next is seems still not factorizable, but we can try to factorize. And because it's 4x squared, so probably 2x squared, and this is 1, so maybe 1. So we check it's true that this is this part, right? So we could take this and write down that, let me put absolute value to make sure that this is positive. So we could take it to integration of 2x squared plus 1 to 2 over 3x cubed plus x from 0 to 1. So 2 over 3 plus 1 and then minus 0. Right? So this will be 5 over 3. Okay. Okay. So the arc length, just remember that you just to keep writing the 1 plus dy over dx or dx over dy and then squared and then dx. Or if you want to use dx over dy, squared dy also okay for some cases. Okay, let's say we are going to evaluate number 16. Okay, number 16. We have ln. Okay, for number 16, we have ln and then cosine x. First thing, as usual, every arc length calculations, the first steps you can do is take the derivative. So take derivative dy over dx So this will be 1 over cosine x, and then multiply with the chain rule of cosine is negative sine x. This will be negative tangent x. And then again, do the same thing as usual for, so adding plus 1 and then square the content. So we will have 1 plus tangent squared x. And remember, the 1 plus tangent squared is equal to secant squared, right? So you can write secant squared x. So basically, what we are going to do is we take the arc length from 0 to pi over 3 to square root of secant squared x dx. And this will be secant x dx. And we know that from what we have done in the previous lectures, that the secant x we can write as ln secant x plus tangent x, right? And we can evaluate from 0 to pi over 3. And we could take the ln secant pi over 2, so 1 over cos pi over 3. Pi over 3 is 60, right? 60 degree. So 60 degree is half, so it's 2. So it's supposed to be 2. And the tangent pi over 3 is, tangent 60 is 1, right? So plus 1. And then minus the 0 is, this is 1, this is 0, so this is 0, so ln 3. Yeah, that's the answer, ln 3. Okay, so I hope you can have more familiarity with the arc length and the surface area. And after this page, I will review from all over the places which we are having our finals, okay? Which topics that probably it will be related to our final. Okay, so if you would like to take notes, you can take notes here. Okay. Okay, I think okay. Let me continue, and then if you have any questions, feel free to write in the chat box, or if you have any requests, which part of the topics that you want to discuss. Yeah. Okay, let me take it to think. this one. Let me just take this. This is actually from chapter 5, 5.3, the fundamental theorem of calculus. And this is multiple answer. It has multiple answer. And I think in your finals, there will be some part of the question that has multiple answers. And you need to select which the answers are supposed to be. So try and see what will be for the answer. And I think it's just normal derivative. Okay, just look at the derivative. I think not really a complicated one here, but just to make sure that you know the definition. So antiderivative, this is just to help out the function itself. So the functions, let me write. So if we take the derivative, this will be x, this is plus, this become 0 minus 2x 2x, right? Or this will be x plus or minus 4x over 1 plus x squared. So it's actually, this is the functions, okay, the functions, and f is antiderivative of this function, dx, okay. So the inflection point of f, so actually this is a derivative of this, okay, and the inflection point will be, so f prime x, or let me write with t to make it clear that this is a fundamental theorem of calculus. Let me write clearly. Let's say this is from a to x. Let's say this is half t squared plus 2 over 1 plus t squared dt. And then the derivative of this antiderivative becomes half x squared plus t over 1 plus t squared. And the second derivative is equal to the first derivative of this small f here. And this become x minus 4x. Okay, now we are just take a look from this functions and observe and analyze. We could see that the x, okay, well, if we would like to take into more So x and then 1 plus x squared minus 4x. We could take this and make it equal to 0. So we could take the x, uh, 1 plus x squared minus 4x equals 0. Or if you would like to take the expansion, we could take it into x plus 2x cubed plus x with power of 4 minus 4x equals 0. So x, or maybe this will be x4 plus 2x cubed minus 3x is equals 0. And x cubed plus 2x squared minus 3 equals 0. Well, we could have, if you want to solve this, it's okay. So x equals 0 and you need to solve this x cubed. We could solve through polynomial divisions. So you could have 1, 2, 0, negative 3. And you could try numbers that I think easy to solve. Like for example 1. If we take 1, then this will be 1. This will be 3. This will be 3, 3, and 0. We still get a good result, I think. And also we can try, so it will be x squared plus 3x plus 3. This will be x minus 1. And from here, I think we could, yeah, I think this is stop here. We cannot really differentiate. But if we take the negative 1, can we still have, yeah, we don't have. So x equals 0 and x equal 1 is our critical points. So perhaps when we check, so when we check 0 and 1, we check through our point. So if we check half, we check half, um, we check through here, half, or maybe we could check 2. I think if we check 2 is positive. I believe this would be negative, okay, because half is smaller than 2, right? Smaller than 2. Because if we imagine half with power of 4 plus 2, half with power of 3 minus 3 over 2. I think 3 over 2 is still large, right? Compared with this 2. So we still have negative. But what will happen if we have negative 1? Let's check negative 1. So negative 1 plus negative 1 is 2 squared. So it's negative 4 plus 4. Oh, negative 1 is also, I think, is also correct. If we check, negative 1 is also correct. So this will be a negative half if we check negative half. This will be plus 3 over 2. So it's supposed to be a positive, and this is negative. So at these 3 points here, it's changing the signs. Well, actually, if you look here, we could also consider to figure out from trial some numbers. 0, 1, right? We check 0, it's 0. We check 1, it's also 0, right? And we should check -1, it's also the 0. So we could also try some guess the number from this fraction. I think it's uh, not too difficult to notice. So that's -1, 0, and 1. The function is the sign is changing, so which means that it is an inflection point. Inflection point is the definition. If you forget, uh, we will see when the f double prime x. Okay, we are going to test. Okay, so second derivative test. So we will have if this is greater than 0, if this is less than 0, this is concave upwards, concave downwards. And when you have the points that is changing from concave to upwards to downwards or downwards to upwards, this point is called the inflection point. So there will be a little bit derivative applications, okay, and then it relates to the fundamental theorem of calculus. Okay, so you need to at least reading out some parts of the fundamental theorem of calculus and some part of derivatives. Okay. Oh, I make a mistake here. It's supposed to be 5. That's why I feel this is not correct. It's supposed to be and this is 1, 0, 2, 0, -3, 0. Then we could check. First is 1. We check 1, 1, 1, 1, 3, 3, 3, 3, 0. And if we check -1, 1, -1, -1, 1, 3, -3, -3, 3, 0. So -1 and 1 is also considered. Okay, so it's true that this is the answer. Okay. Okay, let me move to another example that I have prepared for you. Okay, let's see. Let me check. Okay. Okay, let's move on to next question. Okay, let's say we have this region and we would like to rotate this region about y-axis, and we have the region is bounded by this two curves, the parabolic curves and the line equations. Okay, we could start these questions by imagining uh, the curve. Okay. So perhaps this is curve. Okay. So you will have a point. So you have 0 and 2, and this is supposed to be 1, the maximum, right? I think the maximum will be 1. Or even the minimum, sorry, should be going to be down here. So it's supposed to be, this is 1, then this is negative 1. Okay, now it's rotated about y-axis. Now this is troublesome. If we rotate this through x, I think it's easy, and then we can just use this method. If we rotate through y-axis, we have no other way. We need to use the cylindrical shell, right? Cylindrical shell, we are going to use the volume. So this is the region, okay, the omega region. So the volume will be, this will be the, let me explain here, through the rectangle here. So we are going to use the cylindrical shell. So this is this cylindrical shell, right? Okay. Now this is the height. This is the radius. Okay? Radius is just x. Okay, just x. So 0 to 2 x, or maybe 2 pi x, and then the height is 0 minus the curve. Okay? 0 minus the curve. 0 minus x squared plus 2x, right? Okay. Or if you would like to write in more clear, maybe write like this, okay? And then the x. And then volume 2 pi integrations. This will be negative x squared plus 2x. So we will have 2x squared minus x cubed dx. And then 2 pi, we just take the integrations. And this will be 2 pi eight over 2, 6. It's supposed to be 8 over 3 pi. Okay, right? 8 over 6 multiplied by 2, it's 3. Okay, so this is the answer. Okay. Yeah, if you have any question, you can ask through chat box. So So this is one example in the chapter 6. Okay, that is if you confuse which method you are going to use to compute. Please remember, whenever you have any, for example, let me draw another example. If we have like this, something like this, the curve. If we are rotating here, I think not a problem. We just take this as our r, and then we could just write down the pi r squared, right? The pi r squared, okay, and then for this case, this will be dy, right? So we need to find in the function of y for the r. But if you are rotating through here, which means if we like if we take the rectangle as the disk, the problem that we might encounter is we are not be able to define the boundary. Okay, which one is the function on the top and the bottom, because it's the same curve, right? It's the same curve. So the only method that can solve this without any hassle, without any technical problem, is just uh, take the cylindrical shells, and this is our cylindrical shell. Okay, this will be the radius, and this will be the height. And height and radius is based on the curve, so you need to confirm with the curve what kind of variables it has. I believe this could be resolved through variable of y, because we take this rectangle. This rectangle is dy. So we could have a function of y. And for r, it's best to look on this, right, as a curve, right? So suppose this is g of y, so g of y is our r. Okay? I hope you get the idea. Okay. Let me go through another questions. Okay. Now for the next question, we could have, what else do we have? Yeah, this one. Find the area of surface revolving this curve x equal e with power of y plus e with power of negative y over 2. We have the interval and rotate through y-axis. Okay. So let me give you a couple minutes just to try out and just to see which part that you are having troubles. Okay. It seems complicated, but it has some tricks to solve it. Okay. All right. This one, what you need to do is first imagine that we have just imagine the rotation. So this is rotate about y-axis, right? So we should have in a way that the surface should be 2 pi x, and then the LDL is for the arc length, and because we have a function of y, then we could change this x into function of y too. So x, we could change x to, the function is just this, right? So we could change the 2 pi and then e y plus e negative y over 2 and then dl. Now the problem is the arc length. So we could take the arc length as dx over dy, right? So we could find the first derivative of this, right? So we could take the derivatives as, let me write half, and then this will be e with power of y is just e y, but e with negative y, it will be negative e negative y, right? This is the first derivative. And then we take the squared, so let me write as dx over dy, and then take squared and plus 1. So this will be ey negative y and over 2 squared. Okay. Now let's just take times to look at our equation here. Okay, so 1 plus, we could take the expansions. Now this is interesting. So we have 2 ey and then multiply with 1 over ey, so it's just negative 2, right? And then plus e negative 2y, right? And then this will be over 4. Now we can include this one inside, and we could write e 2y minus 2 plus e negative 2y. Since this is over 4, then this will be plus 4. Okay, so this is supposed to be plus 2 plus e negative 2y over 4. Okay, and this is square root. Now we still need the square root, so we need to find out how to take out this square root. Okay, so if we see here, okay, and if we just take times, okay, if we have e y plus e 2y negative negative y, if we take squared, okay, it will takes the it's cancel one more time, and it's basically make out our solutions here, right? So we could write the s 2 pi ey plus e negative y over 2, and then this will be the square root will be the result is e y plus e negative y over 2, right? And then dy. And then still we have the integrations from 0 to ln2 for this y, right? Now, the problem here, I think we just solve it as usual. So we could take this out, 4, and becomes pi over 2, right? And then we could just take the squared as usual, like we have here. So plus 2 plus e negative 2y, and then dy. And then just integrate as usual. E 2y divided by 2 plus 2y negative e negative y over 2 from 0 to ln2. And then solve for a while. If 0 is all, it will be 0, right? Half minus half, 0, y 0, 0, so ln2. We put ln2 here, so this will be ln4, or this will be 4 over 2, it's 2. And then if we take this ln2 here, this will be minus 4. So minus 4 over 2 is negative 2 plus 2. 4 plus ln2. Yeah, if you calculate, plug inside, it will be 15 over 16 plus ln2. So this will be, oh sorry, so it's 2 is going out, goes inside. So this will be pi, numbers, the answer will be C. Okay. Okay, now other questions? Okay, if you have any questions, you can write in the chat box. Okay, let me give you time for taking notes. I hope you get the idea for the notes here. Okay, let me continue. Okay, this again, it might have multiple answer for this one. So we need to find the value of a, so that the improper integral from 0 to infinity of x with power of a over 1 plus x squared, it will be converged. Okay. Okay, so first thing is we write the integrations. Okay, we look on the equation itself in the inside here. X with power of a over 1 plus x squared. Because it's always positive if we look closely on interval 0 to some infinite numbers. So if we take the positive value, any value that we have, we are going to see that this is a positive functions, right? So perhaps, okay, perhaps because this is positive, we are going to define the a becomes a that is greater 0 or equal 0, and a that is less than 0. So we could have two analyses. Okay? Or maybe giving you sometimes to check whether you are able to at least to conclude the divergent convergent. Okay? Sometimes you can use the p test, okay, the p test for improper integral. And also you can use the comparison test, okay, for testing the integral, whether it's converge or diverge. Okay, now let me finish this. So if we look at the functions, we have 1 plus x squared, which is, if we compare to 2x squared, it's going to be less equal, right? If we use that in an interval from 1 to infinity. And uh, if we could use this fact that this is less equal, then we could also use the fact that if we take this as a 1 over 2x, and let's say this is, if we take a into the denominator, if we are able to, so if this is a x squared, we could write 1 over x 2 minus a, right? And let's say we have this 2x squared as the denominator, and we could have 2 minus a. Okay, and suppose that this is our comparable functions, that this is less equal than the one that we are going to find, that is x with power of a over 1 plus x squared. Okay, now this is on 1 and until infinity. And we know that if we are going to check, okay, the integrations from 1 to infinity over 1 over 2x 2 minus a dx, okay, for uh, for this, let's say this is for a is positive, so this is for a is positive. Okay, for a is positive. So for a is positive, okay, this will diverge. Okay, this will diverge if 2 minus a is less equal to 1, right? Remember that we have this, that p is greater 1, that converge, p less equal 1 diverge. Okay, now from here, so by comparison test, then we know that this will diverge. Will diverge if a is greater than 1, right? Okay. So number D is impossible, right? And on the other hand, if we are looking the 0 to 1 of x a, 1 plus x squared dx, okay. So we are going to have, okay, so actually we are going to have, so 1 infinity is basically, or if we take this 0 to infinity, this is, we can take this, yeah, we can take this to separate the integral. Now we take this x with power of a over 1 plus x squared. This will be less equal 1. And 0, or x a 1 plus x a less equal x 2 minus a. And using the p series from 1 to infinity, that is 1 over x 2 minus a dx, it's going to be converged if 2 minus a is greater than 1. It's like a p series. So imagine this is p. And by comparison test, then the 0 to infinity, the integral, this is ya squared, sorry. So x to the power of a divided 1 plus x squared dx will be converged if a is less than 1, okay, then this number c less than 1 is half, it is available, okay, on the equation. Okay, that's the first case. Okay, let me wrap up this and let me resize all the way here. Resize also. It's a little bit complicated, but as long as you compare with the reasonable functions, I think you should be able to take on. Okay. And for a is negative, we could start with 1 plus x squared. Start with this, and this will be correct when we have the interval from 0 to 1. Okay. And then we take x to the power of a over 2 is less equal x a 1 plus x squared. Okay. And this x is from 0 to 1. Now if we use the p-series, this will be diverged. This will be diverged if a is less equal negative 1. Okay. So of course, now we have the previous one is a is positive. So a is positive, I think it's easier to see. But when it's negative, you will see a counterpart. Okay, the counterpart like this one should be having less equal negative 1. So you have a negative, okay, in the a. So it will be diverged, okay, when you have a is less negative 1. And you will have the comparison or maybe looking at the question itself, this one is not be able to use, okay. And we may have that is less than 1 over x with power of -2 negative a. This is true for 1 to infinite. And then we have convergent or converge when a is greater than 0. So by comparison test, this will be converged if a is less than 0. And we know that we have these compositions, okay, it's always will do for x from this interval. And by p-series, this will be converged in between -1 to 0. And by comparison theories, it will be converged if a is greater than -1. Now from these two statements that the converge series for 0 to infinite when -1 less a less 0. So it should be in between this -1 to 0. So we have a is -half. So B and C is the answer. Okay, let me resize a bit. Okay. So again, if you have this type of questions, one thing that you need to keep in mind is probably the P series test, the P test, which one is the converge, which one is diverge, and then you need to compare reasonable functions. Okay, and then other one is to compare, okay? To compare all the results you have and check. Okay? So check again. So you could put uh, the A, or if you want, basically you could check A one by one. Okay, check A one by one. But at least you can do that after you make out this definitions. Okay, so this is for A positive. Okay, this is for A negative. And also the key important is because it starts from 0, it's best to separate become 0, 1 and 1 infinity. The one that has 1 infinity we can check with the P series. This is also we can check. I believe I have given I think 1 or 2 examples on this one. Yeah. So you could make out. So you can try out when you have 1 over x with power of p for these 2 cases. What will be the interval for p? Okay, for the convergent and for divergent. Okay. Okay, perhaps 2 or 3 or more questions. Yeah. Okay, I think we can try the other question. Okay. The other questions is I think this is the one that we have in the test, right? In the homework, I think. Yeah, I think it's not difficult, right? I believe it's quite easy. What we need is we just take the substitutions first. So when you have use substitution with 2 plus x, then when x is 0, we have u is 2. When x is e negative 2, the u will be e. So we will have from 2 to e ln u du. We could take the integration by parts directly. We could take this, make it becomes integrations and derivative. So this is 1 over u, this is u. So we have these two components. So let me write here. That is, this is u ln u from 2 to e minus, so plus minus, minus integral u du, right, from 2 to e. So this will be e ln e is e minus 2 ln 2 minus, this is become u and becomes e minus 2. So we will have 2 minus 2 ln 2. Okay. Okay, I think it's not too complicated. We just use substitutions and then integration by parts. Okay, now next one is, I think, also in your homework. Yeah, this one, right? In your homework last time. So when we have this, okay, first is perhaps we can make it. You can try to first take the x outside, and then just simplify a bit to make it more, because it has power 7 inside the bracket. Let's make the outside at least having the same power. So let's having this power. So to make it happen, then you need to add x with power of 6. And we can use substitutions. And I think you can see we can solve this, right? But or we could also take out the x with power of 8 outside. Okay. And this inside will be 1 minus x with power of 7. Or rather, this is negative 7. Okay. And the x. And then we could see that this is, we could write x with power of negative 8 up there, and the below is this, right? And then we can directly substitute. If we substitute this with u, if we take the u, this will be 7 x with power of negative 8, right? Okay. And then the x. So we could have 1 over u du, and we need to multiply with 1 over 7. So this is supposed to be 1 over 7 ln u, right? U is 1 minus 1 over x with power of 7 plus c. You can stop here, or if you would like to maybe simplify it, we could simplify it and becomes like that. Well, if you want to avoid mistake that might happen because of the negative, sometimes it's vulnerable for mistakes if you see the different signs, right? Then you could use the first method, okay, that let this a positive power so that you can avoid mistake. Okay? The answer should be the same. The answer should be the same. So you could utilize a substitution method in this way. Okay. Okay. Now let's see the other questions. Yeah, hopefully one or two questions more, and you can study from what we have done here. Let's study how the logic, okay, the process, the steps. Okay. Okay, the next questions is okay. Perhaps let's focus on the number 7 first. Okay, if we are not able to continue to number 8, then number 7 only. So you have the region. It's rotated about x-axis, and what is the results, okay, of the volume and the surface area? And we are given that the x is from 1, so it's supposed to be 1 to infinity, the interval, and for y is from 0 to 1 over x. So it's supposed to be a curve, but this is having a curve of y equal 1 over x, right? And it's actually similar to what we have in the first practice that we have today's practice, the Gabriel's horn. Okay, so you will have simply the same structure for the curve, and it's rotated through the x-axis. And we need to compare the surface. And as we mentioned at the beginning, that the surface is supposed to be infinite and volume is finite. Okay, so I think we can conclude that, or if you want to prove, we could prove the volume by taking the volume with taking this integral pi, and then this is the radius, the curve itself. So this is radius and the x. And if you take this, this will be negative pi over x. Okay, if you integrate from 1 to infinity, and we know that if we take improper integral using the limit, okay, we know that 1 over x will be a 0 for the limit approach infinity, right? So it goes to be equal to pi. So it's a finite for the volume. And the surface, as we mentioned as in the beginning, the surface is infinite. This is the Gabriel horn phenomenon. Okay. And perhaps number 8. Yeah, perhaps number 8. Number 8 is we have a cosine x. It doesn't really have a difficulty here. So cosine x, we could just draw the cosine as that. Bounded with line equal y equal 1. Y equal 1 is probably here. So let's say that's the boundary. x is from 0 to 2 pi. So and it's rotating on y equal 1. So it's rotating here. So this is y equal 1. So this is 1. This is pi over 2. But I think if you rotate this y equal 1, so we just taking the radius here, right? This method, we can just use this method. So taking the volume from 0 to 2 pi, and then the radius becomes this is cosine x. So this is cosine x. This is 1, and the radius becomes 1 minus cos x, right? So we just take that as our radius, and then the x. And I believe you can solve this, right? You can solve this. First is expand this quadratic. At least one type of questions like this will be mentioned, so you need to be able to at least understand the structure. For the squared here, you need to change to cos 2x. Okay? And I believe you could solve this one. Okay, so I leave this to you, and I think we can open for another discussion if you want, or if I have another one, or maybe another one here that perhaps still related to what we have. Okay. So let's say we have this as the concept. Okay, so we are going to rotate the r about the y-axis. So rotate the r about y-axis. So rotate here. Okay. Y equals 0. So it's perfectly in the picture already shown, and you have all the curve. Okay. Now let me give you just the equation, and I will leave that equation to you. Okay. So the volume so we take the 0, 1, and then 2 pi x ln x plus 1 dx. So we are going to directly using the first one is the ln x plus 1, and it's supposed to be plus the other one, the ln x. So plus 1 to t. So here. So this is what we have. First is this. The second is this. Okay. Because we have some boundaries, so we need to separate the area and volume. So 2 pi x ln x plus 1 minus ln x. Okay. And then dx. And then what we have here is the equations. But the question itself is we are having the derivative of the v, the function v, as the limit approaching t going to be infinite. So what we are going to do is we first take derivative by fundamental theorem of calculus. So it's actually combination from several topics. So take the derivatives. Okay, take derivatives and exchange to so for the 1 and t, we could take this because this will be resulting in 0 for the fundamental differential calculus. So we would have 2 pi t ln t plus 1 minus ln t. Okay, and we could combine these two and write down that ln t plus 1 over t, right? So this is 1 plus 1 over t. Okay, and then substitute because t is going to be infinity. So if u is 1 over t, then u is going to be 0. So let's going to change this. We could change to u going to be 0 and 2 pi ln plus u and 1 over t we become 1 over u becomes that. Now we have because this is going to be this is ln 1 plus u, sorry, ln 1 plus u. Let me write carefully. ln 1 plus u. Okay. Because if we took u inside, it will be 0 over 0. So we are using the L'Hopital rule. So 2 pi 1 over plus u. And if we check through our limit, this will be 2 pi. So this is combination as a volume, fundamental theorem of calculus, and also L'Hopital rule. So a lot of topics in one question. Okay, sorry if this is a little bit rushed for the last one. I think this will be the last review for our class. Okay, if you have any questions related to what we have in the topics, or you try the quiz in the platform, and if you find some question that needs to be having some explanations, you could ask me and I will. I think I just offering you just additional video if you want to have like 1 or 2 questions that need to be emphasized. I will prepare an additional video for you. And remember, we will have final exam June 10th. Don't forget to click the quiz, work out the quiz, and also for the final exam, since I think I'm not sure who, but I think someone tried to find weakness in the platform. Okay, so I hope I can provide more subject to the courses, and you can prepare more for your final exam. Okay, do your best. The final exam is open notes, so you can prepare any notes that you have. If you have several devices like digital notes, also fine. Please prepare that. Prepare your time. Study well. Okay. So that will be my last sessions. Okay. So this is the last sessions for our class. So see you on the finals. Okay. Don't forget we have final exam on June 10th. Okay. I will announce on the Moodle. Okay. Yeah. You're welcome, Vicky. Okay. You're welcome, Vicky. Okay. See you, Julio. See you. Okay. So I will stop here.